Good evening. This is the relearning for electricity. Please make sure you have your worksheet out as well. Electrical potential is measured in volts, and the key that we're going to look at is when it is different. We'll look at that in a minute. Current is the flow of electrical charge. This is what we think of as electricity, and we measure this in amperes. Resistance is a measure of the amount of difficulty to pass a current through a specific conductor, and this is measured in ohms. Passing the current through the jiffy clip lead, the wires of our circuit, was really easy compared to passing it through the light bulb because they're made out of different things. Ohm's law is that voltage equals current times resistance. We can rearrange it, still Ohm's law. And we can do some practice. You generally all did quite well on this, unless you made some simple mathematical errors. But if a battery provides 12 volts and a light bulb has a resistance of 3 ohms, how much current flows through the circuit? If we plug in what we know, 12 for V, 3 for R, and then need to solve for I, we know from our algebra that we need to divide both sides by 3, which will give us 4 current, or 4 amps, or 4 amperes. So the answer to that is 4. List what you know, plug it in. When we have an electric circuit, remember you need to have a complete closed path. One of the things you guys messed up on the test was that you saw you needed an open switch. Open switch means that it's not closed, it is not functional. Is not working. So when the switch was open, that was fine. That's not going to create a complete circuit. Then you need a voltage source. That would be something like a battery, something to provide resistance, and then wires to connect the circuit. When we're building a circuit, there's a few things to remember. There's a couple questions on the test and there are a couple questions on the retest that are just making sure you knew what you did in the lab. Make sure that the circuit is closed. Did you close the switch? Is everything connected? And that the wires form a circle. Check that the light bulb is all the way screwed in. Maybe the group before you was testing this. And then checking your batteries. Are they positive to negative? Because opposites attract. The next section, we want to make sure that there is a potential difference. The electrical potential is measured in volts, and there has to be an electric potential difference in order for the current to flow. If there is no difference, it will not go through that area. This example that was on the test was the bird on the wire. When the bird is standing on a wire with both of its feet on the same wire, the voltage at both of its feet are the same. The electric potential on both of its feet are the same. And so current does not flow through the bird. There's no difference, no purpose for it to go that way. It just keeps going through the wire. So there is a current, but it's going through the wire. Now, if the bird steps on another wire, if the electric potential is different between the two wires, then the current will now go through the bird as a conductor, and that's when the bird gets hurt. Batteries are going to be what provides this again. Remember, in series, devices are going to form a single pathway, like a series in a TV show. One thing comes right after another. And these are going to add up. But in parallel, there's a different path for the electricity to flow. And so everything's going to divide. So I hope you got all the notes down. Please go ahead and get this finished up, do the practice problems, and bring it to me as soon as possible. We can get this last standard of the year taken care of, and you can have your relearning done before you take the test, and that should be helpful, the final exam. I hope you had a great Memorial Day weekend, and I will see you tomorrow.